Hello everyone, I'm Daniel. We are students from the Department of Information Management, and our topic today is raw material inventory control, and we use ROCKZ Hotdog for our case today. The following is our team member and our professor, Shufang, Army, Martinus, and me. This is today's outline: ROCKZ background, methodology, supply chain process, conclusion, and suggestion. Let me tell the background first. The ROCKZ Hotdog is a fast food restaurant and established in 2011. The headquarters is in Indonesia and now have 7 branches around the country. ROCKZ's main product is hot dog and burger. Our case is based on an owner overview. This research aims to manage the inventory and the distribution function. Next, we can see a picture. ROCKZ bread supply is on the right in the picture, and ROCKZ has a partner that offers a specific brand of sausage product. ROCKZ has no other supply option because the initial suppliers always complete business order on time. Even if the delivery is sometimes late, the owner accepts it. We focus on the original ingredient used to make hot dog, because most of the company overstocking and unstocking only happen in hot dog. This is the product of ROCKZ. Both of hot dog and burger come with a single or double selection of sausage and chicken. Also, ROCKZ provides chicken nuggets, fries, and some drink. The critical raw material are bread, sausage, and chicken. There are 2 types of bread: long bread for hot dog and buns for burger. And the next part go to my teammate.
Okay, this is Shufang. I'm going to propose the part of methodology. Procedure cover how we conduct the case study. We begin with the problem identification, the data collection, and the data analysis. In the final step, we present the result of analysis and provide suggestions for ROCKZ. Problem identification. ROCKZ has been faced inventory problem with high frequency of stock out and overstock issues. The other problems include when ordering raw materials, the owner didn't consider inventory level, and the owner did not consider the high and low season aspect. Also, besides, the estimation at the right from the average of past demand multiplied by 20%. Okay, yeah. 2 objectives are set to solve inventory problems. One is to minimize the stock out condition while being concerned about overstock condition too. And the other one is to determine when and how much raw materials to order based on inventory system policies. Yes. Okay. Data collection. There are 3 types of data: demand data, seasoning data, and supporting data. Demand data, it is derived from the sales record, and the seasoning data, it is categorized into weekdays and weekend based on high and low seasons. Supporting data, it is used to calculate total cost. Yes. Okay, these 2 tables show the demand on weekdays and weekend of low seasons. Yes. Okay, we use bar chart to compare the gap between weekdays and weekend for bread and sausage demand. Yes. These data are the demand of high seasons. Yes. Again, the bar chart shows the difference in high season. Next, Ami will present the continue.
Okay, thank you, Shufang. I will continue our presentation about supply chain process in ROCKZ products. ROCKZ manufacturing facility is located in the Maumbi neighborhood of Manado, North Sulawesi province in Indonesia, and their warehouse is housed in the same location, and all of our raw materials are kept in the freezer. They buy sausage and chicken fillet from the supplier. and their hotdog stand keeper from each branch collect all the raw materials required every day. The owner orders raw material without pay attention to the low and peak season or unique event. The owner orders the same specific amount every 2 weeks from the supplier. The amount of the bread on hand at the end of the day exceeds the maximum inventory capacity, and then the excess bread is returned to the warehouse at the production location, and it happens to the uncooked sauces as well. The picture below is the influence diagram that identifies the components related to bread demand and total cost. Our new inventory strategy is to reduce overstock in low season and understock in high season. Therefore, the inventory level for bread must be evaluated to discard bread raw materials. The problem's decision variable are the amount of the order and the reorder point. The input comes from the demand data distribution, which corresponding to business actual demand at the particular period of time. The output that will be considered is the entire cost. Economic order quantity is a method or an approach to build a model of an idealized inventory system and calculate optimal order quantity that minimize total cost. The assumptions used in economic order quantity are: first, the number of requested items; two, the second is order item; third, independent and solely orders item; and the fourth is constant item price. And the mathematical equation for economic order quantity can be seen in the two equations here, where the explanation of each variable is written in the box on the right. For the simulation and remaining section will be continued to our friends.
Okay, thank you, Army. Now I will describe how the simulation was conducted. Following tables show the simulation for breads and sauces outcome with economic order quantity model, which compare the result of current strategy and the proposed strategy. Simulating the present and proposed policy is critical to determine if the new policy is more beneficial to the company or not when compared to the current policy. Different simulations are employed to investigate the issue in this instance. For raw ingredient used in bread, simulation with an expiration date is employed. Inventory simulation is utilized for sauces raw materials. Regarding the expiration date, the proprietor indicates that the bread produced may be consumed up to 3 days after producing. If any loaf of bread remain beyond that period, they are regarded as scraps and will be discarded. The amount of bread and the reorder point are being used as choice factors in this simulation. Regarding the existing policy, when the total quantity of bread available exceeds the maximum capacity, the simulation will add the cost of transferring the surplus bread raw materials back to the production warehouse. The extra expense is equivalent to 50% of the daily transportation cost incurred by the owner. For the number of raw materials stockpiled at specific periods throughout the business operation, the suggested policy simulation restricts the number of raw materials coming. For the sauces simulation, the sauces have a 1-year expiration date. Due to its properties, the simulation conventional inventory model is employed rather than the simulation with an expiration date. The simulation uses the number of sauces and the reorder point as choice factors. The suggested policy simulation restricts the number of sauces stored at specific periods at the firm. The rule is dependent on the sauces complete inventory. Thus, even if the order quantity exceeds the full list, the maximum number of sauces delivered at specific time will ultimately be restricted to the maximum number held in stock. When it comes to the wait time for the raw sauces ingredient to arrive, it varies from 1 to 2 days. The likelihood of recurrence of 1 day lead time and 2 day lead time is computed using the number of previous occurrence, the probability technique. For the conclusion, We can explain that on weekdays during the low season, the optimal order quantity and reorder point for bread raw material are 370 and 200 respectively. The optimal order quantity and reorder points for sausage raw material are 600 and 450 respectively. The optimal order quantity and reorder point for bread material on weekends during the low seasons are 550 and 90 respectively. The optimal order quantity and reorder point for raw sausage ingredient are 890 and 450 respectively. Following that, during the weekday of the peak season, the optimal order quantity and reorder point for bread raw material are 540 and 100. The optimal order quantity and reorder point for sausage raw ingredient are 920 and 350 respectively. Finally, during the peak season, the optimal order quantity and reorder point for bread raw materials are 540 and 100 or more. When the inventory level of sausage raw material hits 330 or less, the optimal order quantity is 1050. For the suggestion, we think in this case of bread raw material, we need to balance the maximum quantity of inventory to minimize the transportation cost and the control of 3-day expiration. It means that uncontrolled inventory may have a more significant negative effect. The maximum inventory of sausage is 800, which can minimize the quantity of shortage with megamall only. When owner made an order with the supplier, should consider the availability of raw materials across all branches. I think that's enough presentation from us. Thank you for listening.